Hey guys, welcome back. Today we're going to talk about structs versus classes. So I thought that I would go ahead and kill two birds with one stone here and teach you about structs and classes, but also during the process, I'm going to end up telling you the difference between structs and classes and why you might use a struct versus why you might use a class. So if you would like to skip to the point where I actually just re-emphasize the difference between the two, the timestamp is on the screen now. You can go ahead and skip to that piece now. Now, if you didn't skip to that portion, that means that you would like to learn about structs and classes. So I'm going to go in detail with those. Getting right into it, I have a playground open like normal. The first thing is knowing what a struct is. A struct is kind of what it sounds like. It's a structure that you can put some things into. It's kind of a container, if you will. So let's say you have a person, okay? And a person has a name, has an age, and we'll just say they have a height as well. Cool. They've got three properties. That's great. What we just described here is a struct. So all we would do in order to write this is we would do struct is a keyword, open up the curly braces, and these would of course be properties var, var, var. Because these can change. These would probably be var. This would probably be a let, actually. Cool. So now, if we wanted to, we can call person, open up the parentheses, and it will automatically ask us what the name, age, and height are. And then this will be a person with some values. And we could, of course, store this in its own property as well. Var could be Harold. Something like that. So let's see what this looks like in code. So in code, we would, once again, do struct person. Structs and classes are capitalized. So struct person, and I could say let name. I'll say that this is going to be of type string. And you know what? I'm actually going to keep this as var just for now, just so I can prove a point later. And actually, I don't have to put a value in. I can just say there's going to be a name. I can put age, and that's going to be of type int, and var height, which is going to be a double, which is decimal. All right, so we just made a structure called person. And now we can store a value, a person, in a variable. So we can say Tom equals person. And we can say that Tom will be of type person. There we go. Equal sign. We don't forget the syntax. You don't have to write it this way, but if I'm going to give you any habits, may as well give you some of the habits I've learned from work. So now we are going to call our person struct, and we're making a new value of person. And we can open up the parentheses, and notice it gives us everything that we need right then and there. It says, oh, you need a name, you need an age, you need a height. And so if we hit return, it's ready for us to put those things in. Of course, the name is going to be Tom Riddle. Age will be 5. Height will be 0 or not 0, be 6, 1. Cool. All right, so now if I call Tom, it will give us, oh, actually I need to use dot notation and it'll give us access to any of those properties. So I can call for Tom's name. Tom's name is Tom Riddle. Tom's age is 25, and so on and so forth. So one thing that you'll notice is that at any point in time, I can change the values of these properties. Like age can be changed to 34 instead. Wanted to, and then now if I call Tom dot age, should give me 34, right? The other thing that you'll notice is if I store a value of Tom's twin, let's say, we'll say Tom's twin of type person, and it's going to equal Tom. Okay, so now if I do Tom's twin dot name, it is Tom Riddle, but maybe I don't want that. Maybe I want to say Tom's twin dot name is actually Sam Riddle. There we go. And now anytime I call Tom's twin dot name, that will give me Sam Riddle. And if I call Tom dot name, that will call Tom Riddle. There we go. All right, so let's go back over this. So I had created a structure that is going to have the capability of holding a person. That's just something I made up. This could have easily been car. This could have been a demon. Could have been a plane. It doesn't matter. It could be anything you want. I chose person, and the properties I decided to put inside of it are name, age, and height. If we wanted to, we could put enums and structs in here. We could put functions in here. We could do whatever we want in here. The thing that you'll notice, and the thing that I want you to remember, is that over here, we created a property called Tom. And Tom, we set it equal to a structure, a value of person that has a name that is Tom Riddle, an age that's 25, height that's 6.1, whatever. So it has those values. Then we created a new variable called Tom's twin. Okay. When we made a variable of Tom's twin, we set it equal to Tom. So what I want to make clear is that, and this is your first time looking at this, that's okay. What I want to be clear is that all we did was make a copy of the value of Tom. And now Tom's twin is its own thing. And we can change the values like we did. We said Tom's twin's name isn't Tom Riddle, it's Sam Riddle. So we changed the name. And now we can clearly see over in the gutter here that Tom's twin's name is Sam Riddle and Tom.name is Tom Riddle. So they're containing their own values because we made separate properties. And this may seem like, well, yeah, we expected it to do that, right? Because we made these two properties here, and they store their own values, so they should be different, right? Okay, well, That's where classes come into play. And let's see what happens when we actually make a class instead. So what I'm going to do is I'm going to simply highlight all of this, copy it, and that is Command C if you don't know. Also Command / to comment everything out. I'm going to comment all of that out. And down here, I separated an area for us for classes. I'm going to paste this, and let's turn this struct into a class and see what happens. So first off, there is a couple of different rules, a couple of extra rules involved with a class when creating it versus a struct. A struct was really nice and simple. We were able to just use the keyword struct, name the struct, and then inside of it, we could put our properties and start putting the structure together, right? Class is a little bit different. The way that that works is instead of the keyword struct, we'll of course use class. And right off the bat, it's going to give us an error. And I know it's taking a while for that error to show up, but you can see up top, should be 2 errors or so, maybe 3. So the thing about it is, if you don't define the properties up here that you give a class, it's going to tell you, hey, you need to create essentially it's like a function that is going to be called whenever you make one of these classes, whenever you call a person, a reference of a person. So what this looks like, this is a new concept here. The keyword init is what you will type. I'm going to let Apple do its thing. I'm going to hit return, let it autofill. And it says Swift initializer declaration. This means anytime we are declaring that something is a person, this function essentially is going to be called and ask us to fill some things out. Kind of like what we saw earlier when it was a struct and we just open up the parentheses. It's the same thing essentially. So if I hit return on that, this is our initializer method, basically like a function, and it's asking us for our parameters. A good common practice is to mimic the properties that you have inside of this class as parameters. So we can do that by simply just saying name is one of the parameters, and it's going to be of type string, comma. Age is going to be another one, and it's going to be of type int, comma. And then height will be another one, and it's going to be of type double. All right, sound good? So now, in the previous video, we had mentioned what self is. Self refers to whatever object you might be in at the time, or whatever parent you may be working in at the time. Right now, we are working inside of person. So if I type self, as you can see, it says person here, and I can say dot name. Now, just to reemphasize, we are creating a method that is going to be called, its intention is to be called when a person is being created. So when a person is being created, what do we want to do with those parameters that we type in there? We want to set those parameters equal to the properties. So like this, self meaning person dot name, the person's name property, should be equal to the parameter name up here. So whatever a person puts in there, like we were doing earlier, I put Tom Riddle in, that will be equal to self.name. And you'll do the same thing for the others. Self.age is going to equal age, self dot height is going to equal the parameter height. So once again, all we're saying is that whenever a person is being created, the values that we enter in the parameters should be set equal to the properties of the class itself. And that's how we set the properties without doing like I did here where I said tom.age equals 34, for example. We don't want to have to do that. Tom.name equals this, tom.age equals that. We don't want to have to do that. So an initializer method is something we can use whenever we are initially creating an instance of this object. So now I let everything do its thing the same, and I wonder if you've already realized it. I'll give you a second to see. If you're in playgrounds over in the gutter, it's going to there's something that has happened here that's a little bit different than before, and see if you catch on. Let's walk through this process again. We created a variable called Tom. That's going to be a reference type or a class called person. And so we call person, and let me comment this out for a second just so you can see an example of this. Whenever we're creating an instance of person, that's what it is when you're making a, you're filling out a class. You're making an instance of it when you're creating it. Unlike before, we were just setting a value of person. So if I open the parentheses here, it does like it did before. And it gives us everything we need. We need a name, we need an age, we need a height. And if I were to put in here, Tom Riddle, what that is, you know what's happening here. In the initializer method, the name that I put in is being set to the property name. So going back here, because I already have it all filled out, no need for me to refill it out again. When I call tom.name here, we see that the name property is storing Tom Riddle. However, everything seems the same here. We and ignore this error because it's just a glitch here. For whatever reason, Playground sometimes gets a little buggy. Anyway, we make a variable called Tom's twin, okay? And we set Tom's twin, the variable, equal to Tom. Now, at that time, Tom Riddle is the name property inside of Tom. Okay, that's fine. Then we say that Tom's twin dot name is equal to Sam Riddle. Now down here, we call both Tom's twin and Tom their names. We want to see what the value of their names are. And this time, over on the right-hand side, we see that both of them have a property name of Sam Riddle. So why is this happening this way? Why do classes and structs work differently in this regard? Every time I change the property for this, it changes for all the properties of Tom. I'm going to write this out for you because this gets a little sticky. All right, so we created a person that was a struct, and then we also made one that was a class. what is the difference between structs and classes? So first off, if we create a struct, we made a struct earlier called person. If we have a person and we set the values of that person, like their name and age and everything, and if they are a struct, this is just one value of it. If you were to store this in a property, let's say the property is called X, and you make a new property called Y, and you set Y equal to X, all you're doing is making a copy. These are both going to be separate still. They're going to have their separate values, because what if later I change Y to something else? Y and X are still going to be different. So if you made a class of person, every time you make a class of person, what's happening is there is a spot. You have these little spots in memory. They may not, bear with me, they may not look necessarily like this, or this may not be happening in this exact way, but this is how I'm going to describe this to you. So anytime you open up the parentheses, and this is a class, anytime you create an instance of a class, it is storing itself somewhere in memory temporarily, until it gets deallocated, until it goes away, or the compiler, the computer decides it doesn't need that class anymore. It will get rid of it on its own. It stores this in memory, and if you were to store this in a property called X, and then let's say you decide, oh, I want to set a new property of Y equal to X, this is not a copy. Not a copy. This is still referring to, Y is referring to the same one, the same reference of X, essentially, because X is here right now. So if you were to do something to Y here, you decide that Y is going to change to something, or you're going to change something about the person, it changes it in the reference here. Okay, but if this was a struct, Y and X would be in their own spots. So X would be here, Y would be here. You don't have to worry about this going away. It's only used whenever it needs to be used. And I think that's about as far as I want to go with that. There are some tutorials out there where you can get a little bit deeper into it, but this is the difference. When you have a class and you've made an instance of that class, if you were to store it in a property and set that property equal to somewhere or pass it through a parameter or anything like that, anything you do with that after it's been initialized, it is just passing the reference to the original one that was created at that point. So you would need to create a new instance every time you want a separate copy of that class. Whereas a struct, you can keep copying it and adjusting it, but it doesn't adjust how it looked before. And it's not maintaining a reference to its original spot the first time that it was initialized. So this was a pretty deep topic here. And I congratulate you if you stuck with me through this tutorial series this far. Now that we've gotten through structs, classes, enums, and functions and everything like that, we are going to start stepping into Xcode and start working in the space of building apps. So we still have some things that we need to cover in Xcode, like maybe a tour of the software and how you can navigate. But we have gotten through a lot of the major humps of learning the language. And you'll continue to learn more and more about the language. I'm going to continue to give more advanced tips. But for now, I feel like this is a great point to start stepping into building apps. So anyway, thank you so much for joining me so far. Subscribe if you would like more videos like this. It really helps out. It also helps if you were to leave a like. And any questions you have, please leave them in the comments below. It helps me to answer questions, and it's great to go back and refine the basics. Even though I'm already in my career, there's still a lot that I'm learning every day. And it always helps to have other people to collaborate with or answer questions and explain things in a new way, because it helps my understanding. It helps validate my understanding of those concepts. So anyway, hopefully you enjoyed this video explaining structs versus classes, and I hope you have a wonderful day. Take care.